Hey Timbo. Hi Timbofet. Hi Mia. Thank you guys for joining. Welcome to the AI Incubator. Just getting set up here. Hey Rizzle.
Yo, how's it going?
Good. Okay. All right. So for anybody that wants to be adventurous and view this in world, we're also streaming into the Mona Hub. So I'll get that Hangout link for you now. All right, it's in the chat. All right, so welcome to our AI Incubator. This is a newer event that we just started last month, and the goal with this is just to provide some beginner-friendly, interactive, and creative ways to engage with AI tools, facilitated by guests that have knowledge in the field. And just have some resources and some education for our community in terms of AI, which is a really hot commodity right now. So today we have Bnjmn here with us. If you guys were present a few weeks ago on the community call, he gave us a really cool presentation of his new project, or the new project from the 404. And that project involved 3D generative AI that they also use to create a Mona world, which is really beautiful. So I'll share that link a little bit later too, so you guys can check that out if you'd like. But so today we'll be here in Discord and in World, if you'd like to venture in World with the Hangout link I shared. And if you go into the Mona Hub, to the left-hand side, there's a big screen where you should be able to see this what Bnjmn is sharing being streamed. So cool. We'll go through and I'm just gonna be quiet for the most part today, and I'm gonna let Bnjmn take it away. But if you have any questions or thoughts at any point, you can feel free to unmic and ask or leave them in the chat. And yeah, Bnjmn would love to hear an intro from you, and anything about the 404 project and how that might inspire the work that we'll be doing here today.
Yeah, perfect. Cheers. So I'm pretty excited to host this workshop with you guys today. I must say, I'll give a little bit of a background on myself, some of the AI projects that I'm doing, both 404 and kind of with also some larger communities within the Web3 and gaming space. And then I'll kind of go over a little bit what I think would be an interesting agenda to work with today. So my background is actually as an architect. So I've worked as an architect for the last few years, but I'm also a self-taught coder of about 15 years. And my specialization within architecture was always a focus on computational design. So what I found to be particularly interesting was in some ways, early on, I was showing a lot of architecture work in augmented reality using kind of machine vision protocols, and then tried to start establishing links between machine vision and machine learning, which ultimately led to a 3D generative AI design process that my startup now implements across different virtual worlds. So the startup that I run is called Atlas. I'll put some links in here, atlas.design. We are coming out of stealth mode, hence why we previously were called Malexar, short for Machine Learning Extended Architecture. And what we tend to focus on is, 3D generative design. That's something that right now there's not a very good suite of tools for, a suite of creator tools for. So it's something that we're building out, and we hope to publicly launch a platform later in the year where anyone can go write a simple phrase and then generate that 3D model within a very sort of clean and cleanly modeled environment. And actually that's going to take place in Mona. So that's something we're really excited about in terms of a partnership with Mona. At the moment, and for this workshop, since these kinds of tools are very complex, what I wanted to do was focus on some of the building blocks for that 3D process, which I think could maybe build on what this AI incubator covered in the last time. Because what I believe is you guys looked a lot at Midjourney, so I assume probably some prompt engineering and working to create really sort of beautiful and aesthetic, concept imagery. What my interest is, or what I'd like to focus on today as a precursor to probably another one of these incubator sessions that would focus more on 3D generative AI, is how once you create images or manually model structures that you'd like to use within something like Mona, you can use some really interesting creative AI tools to help you kind of refine that process and even go into like 2.5D, so sort of simple extrusion models. A little bit just more about the creative side of things. So as a company, Atlas tends to work with rather large companies. So within the gaming space, people like Square Enix that want to use us for early 3D concepting, or Yuga Labs for doing things like converting the 2D other side deeds into 3D worlds. We also think that there is so much creative potential on the artistic side for AI use cases, which is what inspired us to do 404. So I'll put here Twitter. So that should be our Twitter account where you can see a lot of the 3D generated content, in addition to actually being able to explore it in an immersive environment within Mona. So that's super, super nice and super interesting. And if anyone has any questions around kind of my background or what we're doing either with Atlas or in the 404, the project 404, happy to jump into that. But I think the reason you guys are probably all here and most interested in is to learn some cool AI tools that you could hopefully use in your own workflow. So I think I would like to start by jumping into that. I don't know your backgrounds in terms of coding experience, and so I wanted to keep this in essentially a no-code solution. If you want to go, what we're going to look at today is a set of tools called Controlnet. Is a set of tools called Controlnet, and when you run Controlnet, or when you run many of these algorithms, and Controlnet is based on Stable Diffusion, so this would be another image generation model similar to what you would have looked at with Midjourney, although the big difference is that Stable Diffusion is open source, and that allows for API access and a much more accessible and editable and modifiable set of tools that you can work with. So when you work with a tool set like this, there are a few different ways that you can work with that. So the most hardcore approach would be to do something like working directly off of the repo, maybe in Linux, would give you the most effective results. But I think that does require a certain level of coding. The next level off of that would be to run it locally. And so I'm just going to show here how you would do that, and I'll provide the links because it's very easy in the case of Controlnet. But together we will actually do this through a fully online API version, so you don't actually have to install anything for this particular workshop. I would like to just put here, though, and walk you through as a little bit of an introduction to this, how one would do this if you get a little more serious about it and you want to kind of be running it on your local machine. So the first thing you'll need is the Stable Diffusion Web UI. That's this link here. It's a link to a GitHub, so you'll need a GitHub account. And anytime you go to a GitHub repository, and I apologize that some of you probably are very familiar with GitHub and will know this, so I'll run through this quickly, but there's usually a README file that gives you a little bit of an overview of the project, in this case, the features, and most importantly, the installation and running. So I've tested this out earlier today just to make sure that this all runs effectively. And if you're running Windows, it's as simple as kind of following their links here to install Python, in a Windows-friendly environment, to install Git, to then, when you see this type of code, this suggests that you can just, exactly copy and paste this directly into your terminal and then run the file just from your folder structure as you normally would an application. And that will launch you a terminal window that has your local IP address, which can then run the repo. Hopefully that's pretty clear. There's also usually a lot of help for this stuff online. This automatic 1111 is a way to install Stable Diffusion. So that's your base generative AI model that you'll be using. And Controlnet, what we're going to look at, is another repository. So I will again sort of just put this into the chat here. And again, in this repo, there is sort of very clear instructions for how to install and use it. So in this case, it's open the extension tab on your web UI, install from the URL, put in the GitHub URL, install it, and restart. In this case, you'll have to download a couple of model checkpoints. So this would be the trained AI model that will be used. And this will take some time because trained models are inherently very heavy files. But I wouldn't suggest that we do this now because this will take some time and can always run into a few small problems depending on if you've currently installed previous repos and different versions, for example, of something like Python. But I did want to kind of provide these links so that if somebody will, after this tutorial, be really motivated to take this kind of workflow to an extensive level, you have all the tools in front of you that you can rely on that. But for most use cases, it will be completely fine to run this online. And so I'm going to put here now a link that I would like everyone to go to. So this is someone's particular page on Replicate. And Replicate is, sorry, is there a question? So Replicate is a website that allows API access to different repos. So it's basically just a web version of the process that we've just spoken through. And so if you go to that page, you should be greeted with something like this. And this is, put together by this user, but they've essentially just cloned different elements of the Controlnet repo, and they've already tied specific model checkpoints. So it eliminates a lot of the extensive work that you have to do. So if you click on this upper right one, the one with the picture of the puppy here, you see how it works. Actually, I'd like to go back a moment. So go back to the main one and let's go to the Controlnet Canny, because I think Controlnet has a few different ways that you can work with image manipulation. And before we go to the overall package and suite, what I would like to do is kind of run through some of the differences so that we can understand how the AI is thinking about imagery, and then subsequently build that into a workflow around image manipulation to get the images out that you're looking for, and even maybe some 3D elements to that. So here, for example, Canny is a specific algorithm for detecting edges in a binary system of images. So the way this and pretty much all of the Controlnet files are set up, and please, if you've had some problems and you're trying to follow along and I'm going too quickly, please flag it, and I'm happy to take a moment to take a break and talk more about the underlying architecture of these systems. What I would like to do is I'd like to give you also another file so that we can all be working from the same basis here. So here is an example of a house. My thinking in this particular workflow is you may have manually modeled some building that you would like to show, for example, in Mona, or maybe you just want to visualize it in a specific way, render it out. Rendering is a very intensive process and can be very difficult. And so this is an interesting workflow, at least to work through some conceptual ideas around the rendering. So as a first step, we can click here to drag and drop a file. You can't see my pop-up window, but you should have popped up a folder window. And then if you select the file, you should be able to load in this same file. I'll just take a break for a moment because I know some of you are downloading the file. Then you have to, once you click this, you have to go ahead and find where it is on your computer and set it. So I'll just give about a few seconds to get that sorted. Great. So assuming that you're now at this stage with me, I'll start to walk through what this user interface looks like. So the first one you're probably pretty familiar with from your workshop on Midjourney would be something like your prompt. So here, for example, maybe I would like this to be a log cabin in the woods. The number of samples is simply the number of images you'd like to generate out of this. Now, this is where already the first limitation of using something like a web API can come in, because I believe probably in most instances here, if you would select 4, you will get an error message that says you don't have the bandwidth or capability or something like that to run it. So we will stick with 1 sample image for now. If you would go through the process of setting up these repos locally on your machine, you could, of course, run as many samples as you'd like, depending on your hardware configuration. Similar, pretty self-explanatory what an image resolution is. These 2 next setups, the low threshold and the high threshold, deal with the algorithm which detects lines in your image. So I don't think you really need to play with them at the moment, but there's simply ways that you can manipulate the output image that we will look at in just a second.
Hey, can I ask a question real quick?
Please.
I'm following along pretty well, but I have an option on my screen that says model type and like canny, isn't it? Maybe I missed a page or something. Or
no, you're right. So I think you've just gone to a slightly different repo. So if you go back to this main page and you click on the Controlnet canny, you're probably on Controlnet. So the thinking is we'll run through all the different model types before we jump into the main one. You would get the same results though, if you would select canny.
Cool. So thank you.
Yeah, awesome. Thanks for following along. Yeah. So here, for example, sorry, I'm just organize my tabs. So here we'll go back. We'll click upload. We have the house, and then the next sort of options we get are the DDIM steps. So I don't know how much you talked about how an image diffusion model like Stable Diffusion or Midjourney works, but essentially you start from noise, and each process, each step in that process converts that noise by looking for sort of embedded patterns in like a machine vision set of algorithms using, in this case, a clip model, and prepares that into an image. And so the number of steps here is how far away it moved from the base level of noise. So from a practical perspective, this means if you lower the number of steps, you will get to your result quicker, but it will be lower quality. If you increase the number of steps, you will get to a higher quality image in the end, but there's a limitation to this. So based on how many steps the encoder model was trained on, at some point it doesn't make sense. So if the model was trained on, 50 steps, you will get some marginal benefit moving up from 20 to 50, but you won't see really any significant benefit moving up. And I think for really most use cases, their default options here are very good. I would just leave it at 20. Scale is basically how much weight to give to the prompt versus how much weight to give to the image, or in this case, the line version of the image, so the canny lines. Seed is sort of your random generator, so this is the random noise that is starts the whole process, and so this is just a way without changing your prompt to look through different options. And the same with the ETA here, it's a different way of changing the noise diffusion process, but it's essentially just the way to get diversity. Then you have two here, and this is something that's pretty interesting in especially these web versions, is what they have realized is there are certain best practices when you write a prompt. So they add to the prompt something like best quality, extremely detailed, and they add negative prompt in terms of low res, bad anatomy, bad hands, missing fingers. All of the things they're trying to, as best they can do, is avoid in the generation. So, all right, enough chat through all of that. Hopefully everyone is caught up. So you can simply go here to submit. And now there's a couple of things that may happen. On your screen, it may give you an error message that says it is, I think it's called starting the model or something like that. And that you need to wait 3 to 5 minutes. That's just simply one of the downsides of using a web API version of this that you wouldn't have if you were running it locally, but it will work. So just bear with it, let it run through. If you really get impatient, you can just reload the page and try again. Sometimes that simplifies it and helps. But here is now the sort of the crux of what's happening on the AI side. So the generation of these lines, I believe the Canny algorithm is not informed by a training process. So this is probably not an AI process. There are some line threshold algorithms that are actually AI trained. That doesn't really matter regardless. This is the result of the lines that you've put in. For example, it would be changed if you had messed up or if you had changed the low and the high threshold. And now this line drawing is what's fed into this particular model. And what's important to understand here is this is not a significant amount of information to give the AI. You can sort of look at it in a binary way. There's either information about an edge condition or there's no information here. So for example, if I will change this to say a brick cabin in the woods, sorry, maybe you've also reached this. Sign up and enter. Oh, I've been using this quite a lot today. Let me make another GitHub account quickly so that I can continue showing this. Sorry about that.
No worries.
If anyone has questions in the meantime, let me, feel free. But otherwise, I just need about 30 seconds to make a new GitHub.
I have a question. There's a limitation then for the use of this?
Yeah, I guess so. I don't really use Replicate very often because we usually run everything either locally or directly from the Python code. But I've been using this for the last sort of day and a half, just running sample generations in order to understand how it would work for this particular demo setup. So I think you probably get maybe something around 20 to 30 generations. So it should be enough for today, but I guess going forward, you would want to, go ahead and make using these kind of Automatica and run it locally. This is similar to if anybody is familiar with Hugging Face, which is another kind of approach. But Hugging Face I think Hugging Face is free, but it tends to take very long loading times because it's free. Okay. All right, we should be up and running here.
Rizzle's dropping some really cool stuff in the chat too, if you guys want to check that out.
Okay. All right, and it looks like once I verify this code, we should be up and running. All right. Let me sign in as Quora. Let me see if now we can get another model here. Brick cabin in the city. Brick cabin in the forest. All right, I can run this locally. So give me 1 second. My user interface will just look slightly different than yours, but that shouldn't be such a problem.
Yeah, I have a question while you're sort of working that out. I'm mashing prompts, and this is fun. Do you have any takes on, like, does it respond well to like adjectives, for example, like a really creepy cabin or a really mysterious cabin, or is it mostly like material and like environment based?
It responds very well. We'll look at some of the different models and which models respond better to those kind of prompts, because it's about which information the AI is getting.
Yep. Cool.
But it should be, oh, I'm still under, sorry, 1 second. Let me sign out.
Another question, while when you have this, how do you download, how can you reproduce it as a 3D object?
Yes, so we will look at that. There's not, let's try this. There's not not a one-to-one solution now. That's what actually kind of our startup is developing, where you would go straight from a prompt and a reference image into a 3D model, but we need to port it as a web service API first. And sorry. But we will look at ways that you can get closer to a 3D model and then use it as a guide, for example. This should work. And use it as a guide for doing further refinement.
That's cool. I know that NVIDIA is hosting at the end of the month one interesting events about AI and 3D objects. So
there are a couple of models out there that go from text to 3D. The issue with them, all right, great, I'm back up and running. And sorry guys, let me share a different window with you. Screen. Sample, just finding the right screen.
Also, if you're working along with us, feel free to drop in any of your results or your works in progress in the chat, the way Rizzle's doing. Would love to see what everyone's coming up with.
All right, guys, sorry about that. We should be back. So, okay, yeah, so to answer your question first, so there are some very interesting developments within text to 3D, which is NVIDIA does one called Git 3D. I looked at maybe doing that as this workshop. The problem is that these generation times at the moment are very long. So it's kind of difficult in a workshop setting to do that, because you'll end up, you need pretty extensive computation power which you can access sometimes through these web APIs, but even so, it still takes a very long time to generate. But it will be super interesting to join that. And I think what I would like to do is for the next, I don't know if it'll be the next session of this, but the next time that I would have a chance to kind of show you guys some 3D stuff, we would work with our own kind of proprietary tools that we've built, because we build off of some of these types of things that we'll go through today. The key for us is always just to make sure that what we generate is very cleanly modeled and easy to work with. So that's something that's not usually apparent in some of the text-to-3D stack that's existing out there. So I just want to answer your question about kind of using these really cool prompts about a mysterious cabin or something. I want to highlight something here, which is that, here I've asked for a brick cabin in the woods, but essentially the AI doesn't really have enough information to do this, because it only has what is a line and what is not a line. So it doesn't have information about surfaces. It doesn't have information about volume, let's say, or an estimation of volume. It only has a very limited amount of information to work from. So if we would go back, which I see some people are already on, which is awesome. So if we go back to the main page and we go to something like the depth maps here, modify images using depth maps, this one, you'll see a very similar setup again. So all of the same things that you're used to. And in this case, what I'll do is I'll put back in our same architecture object, I'll put brick cabin in the woods, maybe. Let's see. And what we should expect to see is that now actually the cabin itself is brick, because what we will see. Yeah, perfect. So for example, what the AI has to work with in terms of an amount of information is it has more kind of like volumetric information. What is foreground versus background? What is almost like a surface that it can work with? And so all of a sudden it's able to understand maybe where brick would go in a much more robust way. And so it depends on what you're looking for in terms of an output from the AI. So if you're looking to experiment with sort of 3D concepting for how your model might look, this is probably a better one to go with. But if you're looking for a little bit more abstract, just kind of artistic inspiration, sometimes using models like with the line work is a lot more interesting. And then little bit.
I'm sorry, yeah. Do you mind just backing up 1 second to the part where you were able to get the textures itself better, like the brick? What screen were you importing or rendering the image from?
Sure. I went back to this this Controlnet one, because the main difference is that here, for example, the input image. So for us, the input image and the text prompt was the same, but we are using a different model now. We are using the Controlnet model that does depth estimation. And so for the AI, the input is this image. So, and a little bit the point here is to show that, in this case, the AI can start to understand a little bit about like volumes and surfaces. Whereas in the other one, it could only understand edges. So when it understands edges, there's not necessarily the information there for it to put a brick material onto a facade. And that's why there's such a dramatic difference within this. And I think understanding how an AI looks at this imagery and how it generates basically allows you to become a very sophisticated user of these AI tools, because you're able to know what types of inputs or influences you want to have in the generative process. And then the other thing that came up is a little bit around the 3D workflows here. And so in this workshop, we are not jumping into the 3D aspect, but there are some very simple tricks that you can start to play when you have, for example, a very nice depth image of your model, or if you would pair that depth image with, for example, a normal map or a line edge model, because you're able to. I'm loving these images that everyone is putting in. Yeah, it's very interesting how you can work around with them, and you always have different kind of options that you can play with here. But you could, for example, now we are looking at kind of an axonometric drawing here of a house. But let's say you wanted to do something very simple, like a shield in a video game. If you would do a frontal image of a shield, you would have here the depth map that would be already something good enough to use as a displacement texture, for example. And you could use then the generated image already as a single view projection on it, and you would have a really kind of cool little way of generating an in-game shield, for example, in a video game. So it gets more complex when you have multiple sort of views and faceted objects like we're working with here, but I think it's still very interesting to understand. So I would like to look at a couple other ones now, just to kind of finish off this view of how the different AI systems are working. And then that's kind of the main goal of today, is just to understand the different aspects of the Controlnet system and how to manipulate them. So we could look at the normal maps. So this is another one where you could work with 3D information pretty well. So here, for example, let's try a prompt that's maybe a little bit more interesting, Darth Vader's house, maybe. I'm not actually sure if that's how you spell Vader, but here, for example, there should be a lot of information about what is a surface and what is not. So we would expect to get something hopefully creative. Yeah, okay, I don't know if that's necessarily his house, but nevertheless. You also do start to see, though, even this is one step up from the depth image. So here, for example, once they're taking normals, this sort of pattern that's on your front facade, covered with a little bit of shading, is able to be recognized under a slightly different attribute than you had in the depth image, which is why you're able to see some articulation appearing here, which was not apparent in the depth image. At the same time, it's understood the window system a lot worse, because in the depth image, there was a greater depth perceived where the window was, whereas a normal mapping kind of wraps it up together a little bit. So it's a little bit just understanding what are these different levers that you can pull when you're creating imagery, and really what the goal of that imagery is. Do you want to use this as a guide for constructing a model? Do you want to use it as a texture that you overlay, or do you want to just use it as a concepting tool? I would also like to show this one as a concepting tool, because I think this is a very interesting one. This is, sorry, let me go back and be a bit slower here. This is the Scribble network, so from Scribble drawings. And I'll give you another file to look at how this may be used in practice. So if we go into the Scribble network, you again can upload a file. So here we take a very kind of nice stylized architecture drawing, and we can say modernist building with trees, for example. And we would hopefully get out something that looks a bit interesting here. I'm loving the lizard. And so here, for example, it's not perfect, but it's a fairly interesting way of visualizing something that's simply a sketch. And the point that I would also like to make with it, so let me upload another file for you, is it really works with anything. So here, for example, is something that I just did on the Photoshop in 1 minute, just to see what happens if we kind of give it something incredibly ugly. We can keep the same prompt, and the AI is really quite powerful in dealing with sort of spatial arrangements from imagery that's slightly, one of the nice things about this stable diffusion is they're kind of aesthetically curated images. And you can get to something that, I'm not sure it's exactly what I imagined in this particular situation, but as an ideating point, it's very interesting to work with and very easy to use, which is also a huge plus. So this is
that design.
Pardon?
That design is awesome.
It's just a nice way that you can, because what I'm trying to talk about here is a workflow that you might work through, where you would try from different images, Yeah, exactly. I mean, this is super nice, using the depth map as a displacement. If you're working, for example, in ZBrush, you could then just cut that off very cleanly. And you have already like a super interesting, structure, or you could imagine that as a whole map and that's some sort of superstructure there. So I think that's like absolutely insane, Ogleta. Yeah, really, really nice. These are the main levers that you have here. The last one that I wanted to show, and then really I think we're good just to play around, is this one, which is a segmentation mapping. So this is one where if we load in our image, it will have a very, very hard time with this. We can leave the same prompt in here, and the problem is, what this illustrates from an AI perspective is we're training data, and being in line with training data is so important, because this has very little information, or is very unlike any training data this data set has ever seen before. There's nothing really it can identify. It's all the same color. It's very flat as an image. And so, yes, it can make something that's aesthetically kind of beautiful and cool here, but it doesn't really have much relationship to your image. It's basically just like using a prompt, because there's no relationship here. But if, for example, let me upload you another file. If, for example, you give it something that's more in line with what it may have seen in its training data, so something like this, it has elements here that it should recognize because it was trained on imagery that was manually annotated, and then give it the same prompt, what we would expect to see is that it understands, maybe what is water, what is building, what is tree, what is maybe even sofa. Yeah, and so here, for example, you get something that is now in line, and you can understand a little bit what's happening. So here you see there was a pool segmented, and there's also a pool here. There's a table segmented here, and there's also a table here. There is some sort of seating arrangement here that's reflected in the blue aspect here and resulting in a seating arrangement. So again, what we are doing now is just plain. We are just putting an image and a prompt. But if you would really incorporate this into your workflow, these are things that actually have control over an AI system. So if you want this same image without the seating, you could download this segmentation image. You could erase out with Paint or Photoshop this seating arrangement, and you could feed it back in as an input to the system. Now you would need to go ahead and run that on a local machine, because you're going to need a slightly more functionality than you have here in the web service API. But it's a very reasonable and not difficult workflow that you would all of a sudden you start going from being someone who just is playing around and putting random images and random prompts to someone that's genuinely using AI as a design partner, because you have actually kind of control over the way you manipulate images. And then the same, of course, applies for prompt engineering. So then, of course, you can work with changing how you write a prompt. You can work with the sort of negative phrasing that you would place down here in the negative prompt and in the positive prompt. So yeah, all of that is very positive. And the last thing that I would just kind of leave you with, and then in the last 15 minutes, I thought we could just play around, or if anyone has any questions, but is you click on the main Controlnet one here, the one with the puppy. This is essentially very similar to what you would get if you would clone or use the repo on your local machine, because here what you have is something called model type, and this is everything that we've looked at. So this is depth, this is hard edge detection, canny edge detection, normals. So to do I'll go back for a second. In order to do the segmentation, I go back to the main repo page on Replicate, and I choose the model which is called seg, the seg model. And that's the one that gives you the segmentation. But if you go back to the main repo, you go into the upper right into Controlnet, this is kind of your master model here. And this is similar to what you would get if you would run it locally, because you can choose now which model you're doing. Are you doing the depth? Are you doing the normal? Are you doing the scribble? Are you doing the segmentation? There's a couple others that we didn't cover. I mean, they're fun to play around with. There's a model here called Pose, which basically lets you, input an image of a person, it will find their body form, and it will generate them out an astronaut or whatever you type into the prompt here. But in this particular demo, I wanted to keep it a little bit focused on architecture and maybe some things that might actually be useful into a metaverse designer, or at least a 3D designer's workflow. So that's, we still have about 10 minutes left, and kind of thought to leave that just to answer any questions. But I really appreciate Olgelta, showing how you've used it as a displacement map, because I think that's where you really start elevating this workflow, that you're using imagery in an interesting way. And at least what we're trying to do in our startup is when we have an image, for example, someone gives us a reference image of a building that they would like to be generated in 3D, we run all sorts of computer vision analysis over it. So we understand where are the edges, what does the depth look like, what do the normals look like, what does the segmentation look like, and we use a bunch of specifically trained models that are looking for certain key architectural elements or key materiality and things like that. And then essentially we have all of this information, and it's just about then putting that into a secondary AI process, which is a generative AI process, where you would create new models based on that in a certain, systematic way. But I think, with this Controlnet demo, you're kind of already half of the way there. And until we do the next workshop, you can already start to integrate and understand how these models work effectively. So that's kind of the end here. Happy to answer any questions, to show any more demos or material. I would really encourage everyone also to check out the Mono world that we did create entirely with AI. So in that case, we generated everything from landscapes to textures to architecture to objects to things like, you can use these tools in really interesting ways. So for example, in the Mono world that we generated, the way that the plants and the flora are scattered is very unique, and they were generated with maps from AI. So you could think about using 2D AI as a height map, or as a scattering map, or there are many kind of very creative games you can play even just within the 2D realm that we also took advantage of in the Mono world. So so that's everything. If there are any questions, just ask. I'll hang out here in the room for a little while longer. But I just wanted to introduce everyone to these tools. And if you think you're going to become a substantial user of them, I really suggest running them locally if your computers can handle it. Of course, if you run it locally, it does run on your own hardware, and so it may be difficult for you, but you always have the option to run it online. So thank you very much.
Yay. Thank you so much, Bnjmn. This was an amazing time, especially for me. If anybody else has any questions, feel free to ask while we still have Bnjmn here.
I have a question. I just wanted to thank you. This has been really cool, and I mashed enough prompts to blow through my free credits and everything, tinkering around. Just curious, are there any other really cool AI tools that are on your radar, or that you also play around with in addition to this?
We tend to build our own tools. Stable Diffusion is always on our radar, because Stable Diffusion is basically an open source platform that anyone can build on top of. And that's really interesting, because you see people building this kind of Controlnet, this is somebody just built on top of an open source tool. I do think the 3D stuff is inherently of more interest to me. So there's something called, for example, I can pull a few. NVIDIA Get 3D is one. We showed, stuff like this. So stuff like this is kind of interesting. I mean, you do sort of see the inherent problem with this, which is that the meshes are completely unusable. So they don't typically work well into a workflow, but they can still be fun to play around with. They don't typically exist in the same sort of flexibility that the 2D workflows do, simply because they're so computationally heavy that you need really powerful hardware to run them, and then that's not usually available for free online. So you have to either have the hardware yourself or pay for it. But I certainly think they're interesting. tools around the 3D side of stuff as well. And I'm really excited for when we will actually kind of launch publicly our suite of tools, because what we tend to focus on is making buildings that look very cleanly modeled. Let me see if I can design. I can show here. So for example, we generated this model, and it's all a very clean subdivided surface. It's super low poly. It just has a secondary one. We generated a material mapping for railing, for glass behind it. Things like this are, it makes it easier for someone to further edit and work with, which is really what we're trying to do, because we tend to focus on the gaming industry, or not just gaming, but like also sort of Web3 and metaverse, where the polygon count really matters, and we're being able to sort of take something as a starting point is really important. So that's what our focus is. But in terms of other cool tools, this is the coolest one, I think, that's not ours, that we play around with at the moment. Yeah. How to get that list. Thanks. We are gonna give Mona basically some of the first testing of it. So I can maybe, if we don't have more questions, I can just very briefly sort of show here, which is interesting, some of the different ways that we've used these tools within our Mona world, just to make it a little bit more clear. But I think there's really a lot of different creative ways that you can take this. So, for example, one of the things that this is a very large world, but I think, I think if we will look, I should be able to show. So, things like this shape here, what's interesting is, it's just about recognizing what are the different underlying forms there from a computer vision process, and then what are kind of the deformations that are applied to them through normal and depth mappings from reference images, trying to understand the relationships between that, and then it's pretty easy to generate a simple form like that. Or if we look out at this sort of larger structure here, this is a little bit more complex, because there are different multiple layers of the generative process, where you're not only going for an overall massing, but you're also going for sort of secondary elements and then populations of those elements based on 2D 2D distributions and scattering maps and things like that. But yeah, I encourage everyone to check it out. I think you definitely have the tool set with this demo to kind of work through, and it's really really a fun thing, if nothing else, just to ideate and concept with.
Amazing. Thank you so much. And if you guys want to check out the world for yourself, I dropped the Hangout link in the chat. It's a really, really beautiful world. So 10 out of 10 recommend. And Bnjmn, this was really great. You already have Arjun asking, will we be back next week? But yeah, probably not next week, but for our next AI Incubator, Bnjmn, we would definitely love to have you for a follow-up to this session if you're interested.
Yeah, for sure. I mean, what I'd really like to do is port our current 3D AI into a web service model, so that we could just let you guys basically play around with it. I mean, I think that would be super cool. We have a couple of game developer conferences coming up over the next few weeks. So it probably can't be next week, but I would love to do another session and focus a bit more on the 3D aspects of where this can go.
Beautiful. Sounds amazing. Well, thank you everyone for joining us today. Hope you guys were able to get a lot out of this session and learn a lot. This has been great. So stay tuned for updates on our next AI Incubator. And if you're around later today at 3 p.m. Eastern Time, join us with Rizzle and Scube's brand new Mona Madness space for some hoops and some basketball streaming. Rizzle, if you want to share a little bit more about that, feel free to.
Nobody knows how this is going to go, so it should be exciting. I know there are a couple of Monoverse hoodies up for grabs. We're just going to give this a shot. Scoop's parcel is really dope. It's got like one of these arcade style basketball games, and Justin from Monoverse is actually incredibly good at it. He's like been practicing for a long time because it's really difficult.